So we're going to take a quick detour into talking about transformers, which are a really interesting application of inductance and inductors. So what you basically have is a couple of coils connected onto the same iron core. And I trust that you can see, using the amazing power of your brain, that if we run a current into here, it's going to, as it runs through the coil, it's going to generate a magnetic field. And I hope you can see that this magnetic field, of course, won't just stay here nicely and neatly inside it. There's an iron core running around, which means it will end up inducing a magnetic field in here. And we know that induced magnetic fields result in current. So what you can get is you can put a supply voltage in here, or a primary voltage in here, and you can get a secondary voltage out here, and you can change that depending on the coils that you use. So this is the symbol for a transformer here, and you can see it's basically like coil, core, coil. But it's the applications that we're interested in. Do we want to change the supply voltage? Say we've plugged it into the mains, but we don't want all that voltage. We want a smaller one. We can manipulate the number of turns on the secondary coil and the number of turns on the primary coil to determine what our secondary voltage is. Let's say we want to step down from 240 volts. We want to step it down to only 100. We can do that by manipulating the transformer. And so even though this is a relatively simple mathematical relationship, it allows us to solve many real-life problems to do with changing voltage when we've got a certain supply or a certain primary voltage, but we want a different one coming out.